Welcome to the Disruptive Innovation Festival, the online festival that asks the question, what if we could redesign everything? My name is Kinga and I'll be your host of today. And in this session, we're going to find out how the internet disrupted the way that physical products are designed, manufactured, and distributed. We are joined today by Christina and Tom, both co-founders of the company Wiki Factory. And that is a social design and production platform. Remember, this is an interactive session. We want you to post questions, comments, and you can do that via the discussion box underneath this session or tweet using the hashtag ThinkDiff. So welcome, Tom and Christina. And my first question, Tom, can you start off with explaining us a bit about the key differences between prior and new models of design and manufacturing?
Sure, thanks. I guess maybe the place to start is the history of the Industrial Revolution as compared with the previous era of crafts and much more traditional systems. So. Of course, back in the day prior to the Industrial Revolution, it was all about craftsmanship, and people used to create much more complex products through craftsmanship. Of course, the Industrial Revolution led to massive standardization of products in order to reduce cost. This led to the kind of industrial production we see now, where most products are all very similar in the way that they're produced, both in the methods of production and in terms of the kinds of, we have all the same kind of chairs made in the same way, all the same kind of desks made in the same way. With digital fabrication, it's becoming much more varied in terms of the kinds of things that can be produced. Complexity becomes a lot cheaper because historically, we would have to set up a production line, so it would require a huge investment to set up those production lines. Of course, then we try and make the process of producing these things simpler and simpler, and therefore the products became more standardized. I think what we're heading towards is a system where everything is can be designed in a kind of one-off, on-demand kind of way. There's a line, I would say, as you start to increase the quantity of things that are produced, where it still is obviously for a long time going to be more efficient to use mass production techniques. But as 3D printing and CNC machines and robotics become more and more advanced, it's going to become more and more the case that we use digital fabrication technologies. So, as the great thing about these new tools, some of them are new, like 3D printing, or relatively new, new at least in terms of their wide-scale usage. CNC being significantly older, but as these things come into much wider usage, then I think that the systems of production are going to change, because we're going to start producing things that have just been designed online, and it becomes a question, theoretically at least, that it's just a digital artifact. So in the same way we've seen an explosion of content in terms of video when video cameras became widespread, people now having them on their phones and so on. I think we're going to see a similar explosion in terms of the kinds of designs that will be online. We'll have millions and millions of designs, and we'll see more and more collaboration around improving those designs. So hopefully we get to a stage, and we're at least right now, I would say, quite far from that stage, but we're certainly heading towards that situation where to start a product design company really doesn't require significant scale at all. And similarly to becoming a content producer on the internet today, it becomes very, very easy, very low barrier to entry to markets. So I want to start a new product design, a new product. I produce the design, I find a way of producing it, and I just linearly scale as demand increases. It's going to have a lot of economic implications in terms of currently we have like in the, what's generally considered the capitalist system, we have like massive manipulative advertising, and that's because people have to invest a lot upfront in order to start producing something. So they have to set up the production line and so on. So of course, then you've got a lot of products which you need then to sell. And so there's a natural tendency for companies to engage in manipulative advertising rather than informative advertising, where they're explaining how something can be useful. And if there is demand, then we start producing it, which is also great from the perspective of inventory for companies, right? Because companies no longer have the requirement to start producing things before they're going to sell them. So this reduces storage capacity, storage requirements. Further to that, of course, then we can have local production, which can reduce transport costs and the like. And there's the very interesting opportunities around these new production technologies, because it's a lot easier to produce some kinds of complex designs. With 3D printing, for example, it's very easy to produce structures which are hollow inside, which have structures internally, where with injection molding, the traditional plastic technique, you can't do that. So I think possibly the most interesting thing from our perspective, though, is the way that it becomes possible once designs are digital for people to collaborate on them and improve them. So hopefully, we can start to see people producing very complex things and innovating on those things to solve real-world problems, improve the environmental efficiency of the products that we use, and repurpose things to solve existing problems, to not be throwing away whole products, but replacing spare parts, because we can produce those things on demand. So yeah, massive social environmental implications, and hopefully massive innovation implications.
Yeah, exactly. I mean, if we are to look at just what is commonly known as the maker movement, that's kind of been hosted in the many maker spaces or fab labs that you see in pretty much every city of the world, it's pretty amazing the stuff that people are already sharing. And it's true that the complexity of those designs are every time increasing, namely because it's that much. It's become more possible for people to become designers or to learn from the work of others, which is fundamental. It's this idea of sharing designs, not only in the hope of having others improve on it, but kind of build a community that could replicate that process for you in any location. Because these machines, they're not big manufacturing plants; they're small little bureaus, or like I said, the maker spaces. And this idea of being able to have a distributed network of local production is very empowering. And you can see it in projects like the Prosthetic Hand project, Enabling the Future, which in many countries has taken on new initiative names, because and what you see with the prosthetic hand case is this idea that there was this need for customized prosthetic hands for children in need, because the current market is very expensive. In fact, it's so expensive that kids would have to wait until they became adults to purchase their prosthetic hands. But there came about 10 years ago, at the start of this kind of maker movement, this young guy shared the RoboHand, the first design, open source design for a prosthetic hand. And at the time, the maker movement was just about starting, so it definitely caught people's attention, and it continues to do so. But what you have seen, as more and more people have jumped on board, is that not only is there more than one RoboHand, there's about 20 different designs, and it's no longer housed within one initiative only. There's people who have completely taken it to to different avenues of development, where they're making it more bionic with electric signals. But what you have now is thousands and thousands of people working and improving on the design, and people who are not even designers just becoming really good at manufacturing them and assembling them and being that kind of point of contact for those who need it in the local level. So it's really a perfect example. And I mean, I like to cite that one because the difference of cost is just really, really considerable. Instead of thousands of dollars or pounds, it literally can cost $100 to make one of these customized prosthetic hands on demand by your local maker. But this kind of impetus to share and to kind of mimic the kind of developments of open source software is seen across the board in pretty much every product vertical, whether it's for things like beehives, housing with WikiHouse, for example, that's a great one. Or with OpenROV underwater robots, with turbines, open source lab equipment, so you can actually monitor water quality in developing countries. There's, in fact, for me, the thing that inspires me most is that there's people who are picking out the kind of the plethora of collaborations that is happening on different product verticals. There are people who are selecting a few that are better developed and establishing makerspaces in the very periphery of our society, or let's say for the base of the pyramid for developing nations in places that are more remote, and being able to offer on demand the production of these traditionally high value or expensive products. And that's extremely significant. Because, I mean, that's significant from the social perspective, but you even noted, Tom, about the environmental aspect. Because if it's printing on demand, not only can you, not have inventory, like you mentioned, not have to produce in bulk, you can just produce the one-off. Well, that's definitely more sustainable. But even the materials used, I mean, this is more blue sky thinking, but there's nothing to say, there's nothing stopping us from moving towards a more circular economy route. And actually there is evidence. Actually, it's not so much blue sky thinking. There's people working on this where you can recycle the material used in 3D printing. So it actually costs nothing in terms of material cost to make things like the prosthetic hand. So whether it's more circular models that are circular economy models that are sustaining the production models of this idea of a local distributed local production model, or it's actually down to how you design things. A lot of people are designing things more from a point of view of being able to disassemble them, and like you mentioned, Tom, being able to replace certain components. If you know that things can be some parts can be produced where you don't, to replace something, you don't have to produce the whole thing, but just a modular part of it. And having that in mind, designers are reacting to that and designing things far more in a modular way so that things can be assembled and disassembled at ease.
I think that's very interesting, and maybe also good to hear some. Do you have some case studies, or for example, with the company that you founded, Wikifactory? Can you tell us a bit more in that direction?
So yeah, I mean, there are an increasing amount of the filament reuse systems. So you can melt down the filaments which have been used in existing 3D prints, even 3D prints that failed. You can crush them up basically, and then remelt them and reuse them again on that front. In terms of replacing spare parts, we know that a lot of corporations right now are looking at that. One of the more interesting contexts is Australian mining, actually. So in many cases, there are mines that are many thousands of miles away from nearest factories, and they're starting to use very large-scale industrial 3D printing to replace those like broken parts for large machinery in place, rather than having to transport them thousands of miles across the outback. So I think that to a large extent it's about the potential. I don't think we're only seeing the tip of the iceberg right now, but there are massive opportunities to start doing that. Yeah, in pretty much every industry.
So we have a question coming in already. The question is, hi Tom, you quickly mentioned the environmental efficiency effect of the new model of design and manufacturing. Could you elaborate a bit on that?
Yeah, so I think Christina kind of did already kind of react to that in real time to a large extent, but maybe to recap, it's about material reuse. It's about not throwing away old whole products, but replacing spare parts. And it's about local production, so we don't have many oil miles or gas miles in order to get products to people. So I think they're the main things in terms of the kind of hard. Other aspect is really about collaboration on designs and having people, where we're iterating constantly on designs, then it becomes possible to continually improve the environmental performance of products, rather than them being a kind of fixed product which you have to wait for version 2, version 3, and the best ideas don't necessarily get incorporated into those products.
Yeah, exactly. And to allude to the question you asked, Kinga, why Wikifactory? Well, we kind of are hoping to resolve exactly what Tom is mentioning. There's all these initiatives that are wanting to share and collaborate with others in the improvement of their open source or non-open source designs, for that matter. And there isn't really that framework or that platform in place for you to do that. There are places where you can share designs or things more like, but what we have found is that in trying to replicate the process of making something, say the prosthetic hand or whichever design, it's not just about the thing at hand. It's not just about downloading the design and pressing print. There's a concrete process that is happening, which we would like to think is as plug and play as go ahead and print it, but it's not there yet. And in fact, even if it were that way, there's a feedback loop that needs to be captured, a feedback loop in being able to present an idea to a potential user base. And on that same day or a few days later, whatever the time schedule, get a response of how it can be improved, and be able to roll out a better design. And it's not only in terms of product improvement, but actually customize it to those unique needs of those people who are responding to you. So I'll use the prosthetic hand case because it needs to be customized per use case to the dimensions of each child. And therefore, you can really quickly respond to the needs of your community. If tomorrow you receive new dimensions for a new case of a young girl that needs a hand, that same day you can rescale and customize that design and have it made locally, and within a few days be able to resolve that person's need. That's amazing, and we feel that we want to kind of enable that efficiency in sharing of designs, the documentation of how to make it, so you can involve others in that feedback loop. In many ways inspired by open source software, and because open software has this, right, Tom?
For sure. We could talk about that, or should we go to some of the next questions?
Yeah.
No, you can talk about that a bit more if you want. I think it's an interesting topic that you got onto.
Sure. So, I mean, there's, in terms of open source software, of course, there's been this kind of collaboration going on for a long time, and it's now a huge community. probably centered around the website github.com, where most of the world's software developers release their work, contribute to projects, and reuse projects that each other have developed. So one of the trends there, of course, is, as with most software, you have libraries, and so whilst I'm basically reusing someone's work, I'm not necessarily like changing it or redesigning it. So it's a question of to coin a phrase, or to rather repeat a phrase, not reinventing the wheel. There's that good to see that start happening more in the product design sphere, and there are projects that are working on reusable kind of components. One of the most interesting is called open source ecology, where they basically take like a small set of machines that can be applied to creating something like a self-sustainable village. So a lot of farming tools, a lot of building tools, but all componentized in a way where different components can be reused and repurposed. I think what's lacking is the kind of platform and infrastructure, and that's very much what we're trying to focus on at Wikifactory. So how can we provide the infrastructure first, which allows people to collaborate in some of the ways that have been shown to be very effective in the open source software community? So providing the version control tools, providing the tools for tracking the issues people have with projects and responding to those, providing very good documentation. But more so, I think where things are going to get very interesting is almost where 3D printing has already proved itself as prototyping. And the interesting thing there is you have this kind of design, build, test cycle, which we also have in software. So in software, it's very important to do what we call automated testing, because every time you make a change, to be able to to be able to run your tests and know after you've built the software, does it work, and then go back to the design phase. And the quicker you can do that, then the faster iteration cycles become. And the quicker innovation becomes, therefore. So it's really about in the product design world reducing the time that it takes to go from I produce a design, I make an initial build, and then I test it, and I go back to the drawing board and start again. The part of the kind of area that we want to tackle really as Wikifactory is how do you there are a lot of great design tools out there, and there are now some great machines for automatically producing. But what we haven't got is the tools, the software tools. Actually, this is the bit that people kind of miss, is that it's a huge gap between having a digital design and being able to produce it. People who haven't tried 3D printing have this kind of idea that it's very plug and play, right? You have a design and then it can be produced, but actually there's a software pipeline of transformations you need to make. That's being done on the desktop. As a result, kind of it being done on the desktop and not in the cloud, there's kind of lack of learning. So people aren't really learning. I produced this particular design with this particular material on this particular machine, and this was the result. And not only that, but this was how I processed that design into what we call machine code. So similarly to how you have a driver for your printer, which determines how you're going to print this particular document. So it works out what the path for the print head to take. It's the same in actually 3D printing or any digital fabrication technology, that you need some way of driving the machine. And what we haven't got is that kind of scientific data as it stands in any kind of open way. This is certainly happening in big corporations that are trying to push the boundaries of what's currently being called Industry 4.0 or the industrial internet. Whereby you've got Internet of Things sensors that are on the production machines that are feeding the data back into the production process, back into kind of creating loops, so that we can feedback loops, so that we can like optimize the production, even fix problems as the production is progressing. And what we're trying to do, what we hope to see happening more and more, is this kind of like an open version of that. Industry 4.0 is all about, you know, big corporations finding more intelligent ways of producing things. And what we're very interested in is how can that be applied in a more open, disruptive kind of way.
So yeah, you're talking about this big movement from the traditional to a totally new way of producing manufacturing. And we have a question around that, and I think I want to rephrase the question a bit because parts of it you've just answered it already. But who would be the target group of this movement? Who would be the early adopters, and how do you see that movement going?
Yeah, great, because it really is this kind of maker, say, target that is emerging, and maker is actually more of an attitude. So it really can be any designer, any engineer, any developer or hacker or hardware developer that is interested in getting more involved in the process of making things, whether it's not just design, but also in the fabrication process of it. And these people can be standalone individuals. They come together and form initiatives. Some of them get involved in campaigns. Like, actually, even respond to that question, is there this kind of movement? Well, it's fair to say that, for example, in the case of local motors, which have rolled out a very effective model around, let's say, catalyzing the interest amongst makers, specifically in car manufacturing, by rolling out this idea of these local factories across the United States. It's a play actually on General Motors. So local motors establish these small factories and involve designers in kind of co-creating their next car design, and these local factories can fabricate them. And they're a very good case of a very well-funded initiative, a distributed initiative. They got, I think, they were very well-funded by Airbus. And since then, they've kind of replicated their campaign model involving designers and makers in this kind of open process, specifically with their, I think it's called Launch Forth, sorry. And they partner with different corporates like HP on Mars. So any potential engineering project around for our future inhabitants in Mars can launch campaigns in Launch Forth to catalyze the interest amongst makers, designers, engineers to suggest ideas. They actually, it kind of falls short of anything further, because that's, I think, the tricky part, and that's maybe where Wikifactory tries to enter, is not just we want to take early formed and well-formed ideas to the next level, which is the kind of gap in community platforms that we've seen. But definitely, like, this maker movement, I could say it's a specific target, but it's more of an attitude, and that kind of attitude we are already seeing in universities too. So
and I would add to that that whilst it's true, very much our target group is very much the kind of individual makers, the people with the kind of hacking attitude. There are more and more corporations who are interested in this, and that are seeing the opportunity. For example, you know, I was talking to some people from the Danish Design Center who just last weekend, and they were talking about Bang & Olufsen, who, you know, very high-end design company, and they've just begun for the first time putting an open source product in their stores, which is, I believe, a Raspberry Pi, which is used for retrofitting old speakers, so that you can control them from your mobile phone and so on. So you can take, you know, like the really nice old speakers and retrofit them with this this product. But it's completely open source the way it's designed, so they don't want to kind of get left behind. This you know, revolution in design happens. And I think more and more companies are seeing that opportunity. You know, similarly, like Christina was saying, you know, Airbus seeing the opportunity to start to engage in those production processes. yeah, then of course there's the people that run the machines, and that increasingly we're seeing service bureaus opening up, which offer 3D printing services on demand, which offer CNC. With CNC, it tends to be smaller shops. But what we need to see there is also with the larger corporations. General Motors have set up a micro factories system as well, but it's kind of very much internal at the moment. But it's about seeing that production capacity opened up to the wider open source community as well, because I think that'll be add a lot of power to the maker community, which I think is increasingly recognized by the corporations as where the innovation is starting to happen.
Yeah, I think you're totally right on that, and they are starting to get to see that importance as well. But would you see the way the 3D printing and all the technology is being used would be different for individual makers than for the big corporates?
Yeah, I mean, I think certainly right now, I mean, there's organizations like 3D Hubs which offer, I can put my home 3D printer online. It makes it possible for me to, for someone to connect and give me a print job, and maybe I can make a little bit of money out of that. But right now, the consumer level 3D printers, are very, very low spec, and the level of failures and error rates is quite high. So partly that's to do with the hardware and the maintenance of the hardware. So I think it's going to become important for that hardware to be provisioned in a slightly more professional way, even for the makers, if they want to start scaling their production a little bit, if they want to start improving efficiency. I don't think it'll be a question of I hope it won't be a question of like one dominant market player providing everyone's production needs, but I think that we'll certainly head towards kind of local factories which are semi-specialized, which can produce a wide variety of goods with like a limited set of machines, and maybe varying distances from your home. A varying level of specialization, as it were.
Yeah, and to go full circle with some of the things that you were mentioning earlier, Tom, I think both the local maker or the designer or the big company, all of them are wanting to have more of a conversation with the end consumer rather than presuppose what the consumer wants. It's actually engaging them from the get-go in the process of co-creation, in the process of customizing their product, because that's in effect what the consumer wants. People want to be more involved. People have a better understanding as to what they themselves like. They don't need to be advertised and sold as to what they necessarily want. So I think it's about that conversation and kind of enabling the consumer to write out what it is they truly want.
So you mentioned that there is this huge extra flexibility involved in the way you can produce in this with this new methods. Is that like, to kind of wrap it up, is that the biggest disruption of this new method, or would you give that something else?
I do think that's a huge thing, because as it becomes, the machines have become more generic and as you say, more flexible, then there's massive opportunity to, it basically makes linear scaling possible, where if you think historically of a whole production line, not just one machine, but a whole production line being set up to produce one product. If we can have a small production line that's flexible but can produce hundreds of products, a machine in the ideal, then of course it's going to create massive efficiency gains in producing at low scale. Of course, also one thing we haven't talked about that much, I suppose Christina mentioned, is customizable products and personalized products. So that becomes a lot lower cost. And the prosthetics being a key example of that.
Exactly, because the printer doesn't care if you tell it to make 1,000 of the same thing or 1,000 slightly different things. And that's the core aspect, because it might be 1,000 versions of the same thing, so enabling customized products, or what is more truer to the current panorama, although we are getting towards this mass customization vision.
Okay, I think we kind of had a blowdown in the end up there, but we actually got into really great conclusions. So I think I want to leave it to here. For everybody viewing online, if you have still questions coming on, also when you look back on demand, I think our speakers will be happy to answer them later on.
Absolutely.
Thank you for being us, Tom and Christina. I've enjoyed the talk a lot. And for everybody watching online, thank you for being there. We have many more sessions on great disruptions going on. Also today, we have a guest in our live studio who's going to talk about robots, and maybe robots are a good thing, the robot invasion. So tune in at 5 p.m. for that. And that's it for me for now. Thanks a lot, everyone. And goodbye.
Thank you very much.
Thanks, Kina.